Okay, for this Java applet, I'm going to create a simulation of a bouncing ball. Right. So you can see that in the EJS working window, there are three main sections: a description, model, and the view. Right. The description window simply allows you to add a written explanation of what your Java applet is all about. Right. So for example, I can click on it, right, and just say that this Java applet demonstrates a bouncing ball. Right. So whenever this Java applet is run, once it's created, a small window will open up showing this very short explanation to the user of the Java applet. Okay, so the description page is rather easy to understand. Okay, we next go to the model page, right? Okay, the model page is where your understanding of physics comes in, right? So for a bouncing ball, you have to consider what are the variables, right? So let's click on this page and to create a list of variables. So I'll call it the list variables. Okay, right. So the very first obvious thing about a bouncing ball is the position of the ball. So I double click and call X, give it X, and this X will represent the position, the vertical position of the ball, right? I can give an initial value to X. Let's say I want X to be 2 meters at 2.0 meters. So I double click and click 2.0. Right? You can see the type of this variable is double. Double simply means that this variable X will be represented in the computer using I think 64 bits, right? So it's rather accurate. Okay, another variable important for a bouncing ball would be its velocity. So I double click V, and I'm going to set the initial value to be 0. I'm going to start the ball from rest. Okay. Okay. The third variable involved in this simulation would be the time, right? Obviously, right? So T, again, naturally we start timing from 0, right? So from 0. Okay. What other variables are there? Acceleration is the rate of change of velocity, so I do not need to declare it as a separate variable. Okay, so I think that's enough, right? Initialization we can ignore for the time being. Now we go on to evolution. Evolution basically defines how each variable will evolve with time or space, right? As shown in the pop-up window, pop-up phrase that you can see. Okay, so let's click on that. Right, I'm going to represent the physics of the falling motion using a pair of ordinary differential equations, ODE. So I click on this. I'll simply call the page evolution. Is it? Okay, right. Okay, so now you can see that this page is asking me to write down a set of differential equations, ordinary differential equations. Okay, so if we go back to the variables page, we can see that there are three variables: the position X, the velocity V, and the time T. Okay, evolution is asking you to specify how each variable will vary with another variable, right? So in this case, obviously we want to see how the position of the ball varies with time. So the independent variable is obviously T, right? And since we are running this Java applet, this simulation on a computer, the computer will run this simulation in cycles. So what is the time taken between each cycle? So I'm going to set it to be 0.01 seconds. Okay, so that is the dt. Right, next I click on this and type X and then press enter, and you can see dx by dt, and as everyone knows, dx by dt is simply the velocity. So you can see that I've managed to relate the variable v to the variable x and t as defined in the variable stage. Right, so what is the other differential equation? The other differential equation will be talking about the acceleration of the ball, which is dv by dt, and everyone knows that that has an actual value of g, acceleration due to gravity, minus 9.81. Okay, so by putting a minus sign here, I'm of course defining the downwards direction as negative and the upwards direction as positive. Right? Those are the only two differential equations we need, so I'm going to cancel the third equation. So I right click, remove this equation. Okay, we seem to have finished the declaration of variables and the evolution. Okay, what happened? Let's try that again. Okay, let us save, give it a name, falling ball. Okay. Yes, I'm going to write the author, that's me, then press OK. Right, so I claim ownership. Okay, can, right, let's check one more time. Okay, the thing stays put. Okay, I think we stop here and save the recording.